Welcome back to another security news bites. Okay, the first news, Nike, the company which got famous for manufacturing sports goods and uh, wonderful shoe wears, is in the limelight. Why is that so? Because this pair of sneakers, which costs around like $350, could do self lacing itself via a motor inside this particular shoe. So it was supposed to be an instant hit, but rather what happened is because of a faulty update to an Android version of the Nike app, which controls the shoe's tightening mechanism. This shoe prevents to get its lace tightened up automatically based on the app. So the users have started venting their anger out in social media pages, and Nike says that it's working on a fix, but it's not sure when a patch would be rolled out to the customers. Then iPhone users of this particular app is not reported to be affected. So going on to the next story, wherein Rontok ransomware. So once it infects a Linux server, it wants 75,000 US dollars, which is 20 bitcoins. So what happens is when Brontok encrypts a particular file, it will encrypt it and then do a base 64 encoding on it. That's how you know that your machine is affected with Brontok ransomware. On top of that, it would change the file names. It would take the file name, encrypt them, then do a base 64 encoding, then an URL encoding, then append .rontok towards its end. For example, a file name could appear something like this, followed by .rontok. So if you were to follow to the URL which is there for paying the ransom, it asks you for your UUID, which the malware provides you with one. Then if you provide the UUID, it provides you with the QR code for scanning and paying the 20 bitcoins. So when you pay the bitcoins, then you get probably the decryption key. So when they tried looking at the source code of this particular web page, they were able to see Vietnamese hacker. So it's probable that the tool itself was written by a Vietnamese hacker, but it was deployed by somebody else. Going to the next story, one more time, ransomware hits payroll company, and the payroll company had to pay the ransom to get the files back. So the company which we are talking about right now is called as Apex Human Capital Management. They serve almost 350 companies payroll services. So they had a ransomware attack, and the important thing is that their backup site was also affected in it, rendering them unable to retrieve the data back. So ultimately they had to resort back to paying the ransom to the ransomware person to get their files back. But the decryption key did not do a very good job, is what is being said as per Crypson security. Partially the files were recovered, but not in the correct respective order or something like that. So if you want to prevent yourself from ransomware, these are some of the best practices which you could take. One of them is backup. There is something called as 3-to-1 backup approach, which I learned something new today, wherein 3-to-1 means 3 different types of backups needs to be taken. Three backup needs to be taken of your data, out of which 2 needs to be on different storage type. Like one could be on NAS, another one could be something else. Then one should be on a backup site which is like offsite, not connected to your computer or your network. So retrieving the data from there should be possible for you, but should not be very easy for you. So you should be able to retrieve it in an hour's time or something like that, but never connected to the internet kind of a thing. It's like an offline backup. So apart from that, there are some more best practice recommendation, which is you have to patch early and as often, because attackers often use the unpatched software to start spreading their ransomwares. Then disable remote desktop protocols if you have it enabled on your machine, and please, for God's sakes, do not enable it on an internet enabled device, internet connected device. or like from where you could directly RDP to a mission over the internet, please disable RDP there. Then filter for all emails, try to look for emails which has malicious attachment in them. Isolate mission critical data and non-critical data. So in your house you would never put your jewelry in the place where you would put your normal vessels, right? You would definitely isolate them. So try to treat your mission critical data systems in a separate place compared to your normal systems. Then backup key files and database, which was covered in the last slides. Then try to disable macro and office documents. Then the last one is something interesting, wherein you can try to control executables from getting executed from certain folders like app data or local app data or program data or temp. So most of these ransomware try to run out of these directories. If you kill any executable trying to run from these directories, you try to prevent the ransomware from getting run as well. So you would get yourself protected against the vast majority of ransomwares, unless until they really know that you cannot run from these folders, and then they try to jump to another folder and run from there. Tax returns got exposed by TurboTax. So Intuit has informed its customers that some of their tax records were exposed through a breach, and their accounts are deactivated. And this guy called Adam, he comes out with a wonderful phrase saying that human nature is the fuel within the credential stuffing mission. So which means that if you use your credential in one place and reuse the same credential at a different website, then you are basically a fuel for this credential stuffing mission. That's if your email address is typically your username and you use the same password across all your websites. Say you have your Gmail username and password and you use the same thing for logging into your Facebook, then you are ripe for the picking by the attacker, is what this particular user says, and it's wonderfully put. So the moral of the story is try to use a password manager. My advice would be, do not use a password manager. Do not show your credentials on the same computer where you expect it to get infected. So rather you try to save your passwords on a different medium, right? And that medium should not be readily readable by anybody except you. When you try to look at the medium, you should know what your password is, but anybody else who's looking at the particular medium shouldn't be able to recognize what your password is. So the next one is with respect to millions of users' passwords are being stored as plain text by a utility company in the United States of America, is what I know from this particular link. So a security researcher forgot his utility password, so he tried resetting it. Without further ado, he got an email from the utility provider saying that here you go, this is your password. Instead of the best practice of giving a link to the user asking them to reset the password, if a link is provided, it means to say that the utility provider himself does not store the password, but in this case the utility provider returned back with a clear text password, which means to say that the utility provider is having clear text passwords saved on the database. And time again what we used to see is, once the attacker breached the website, the first thing which they try to do is dump the passwords from the database and try to reuse it elsewhere. So in order to prevent those things, in the security community, we advise the database admin not to save the passwords in clear text in the database, rather to hash them and then save it. So that's the best practice. And if you are one of those companies who save passwords in plain text, should a breach, touchwood, breach shouldn't occur, should a breach occur, then you are in a very tough position to defend yourself. Next one is with respect to ICANN. They warn about large scale attacks on the internet infrastructure itself. What do they mean by that? They mean that DNS is being targeted. That's what the chief technology officer of ICANN, David Conrad, said. So what DNS is, domain name server. This is akin to your phone book. What your phone book would do is you would know your friend's name but not their phone number by heart. You would just look up the friend's name and just look up what the number is, then dial in the number, right? So that's exactly what happens when you open up a browser. You wouldn't directly type in an IP, rather you would say google.com or example.com. The browser takes this particular value, goes to the DNS server and tries to look up what the IP address corresponding to google.com or example.com is. When the IP address returns back to your computer, your browser would initiate a connection back to the IP address of google.com or example.com and try to fetch the home page of google.com or example.com. And recently they are seeing that changes to the MX record, which is typically used for emails, A records typically used for web pages, and DNS redirects happening. And to prevent all these things, ICANN is urging that DNSSEC technology be implemented as soon as possible for .gov related websites. So with this, we come to the end of today's security newscast. Thanks a lot for watching this video. Bye bye.